Hey boys and girls, hope you're doing well. We are going to go over Chapter 5, Section 6, and the name of this is Add Linear Expressions. Alright, so adding linear expressions, it's one of those things where until it clicks, it looks really difficult, but it's not too bad. Basically, the linear expressions, they're algebraic expressions where your variable is raised to the first power, and we're going to learn how to add these things. So, best way to show you this is with examples. So let's take a look. Let's say I had 2x plus 3. There's one expression, and I want to add this expression right here. So basically, what's going to happen is I'm simply going to add like terms. So first thing I'm going to do is I'm going to get rid of these parentheses since there's nothing outside being multiplied by the terms inside. So I'm just going to write this as 2x, I get a plus 3, plus, there's nothing in front of that x, so just plus x plus 4. And what's going to happen here is I'm going to say, alright, I've got two x's here, and I've got an x right here. Now this is a plus x. If there's nothing in front of the number, and the leading one, if it's positive, won't have it. So if there's nothing in front of the number, assume it's positive. If it was negative, they'd have to have a negative number there, or a negative sign, pardon me. So we've got two x's plus an x. Well, how many x's is that together? If you got two x's, you add another x to it, now you got three x's. So, 3 x's, I'll cross those out because I used them, plus 3 plus 4. Well, 3 plus 4 is 7, so now I have 3x plus 7. And that's my answer. I don't go any further than that. I cannot add these 3 x's to the 7 because I don't know what x represents. This x could be 100, it could be 2, it could be 5. I don't know what it is, but I know I have 3 of these x's plus 7. Let's take a look at another example. Say I had 2x minus 1 plus, let's do this, a linear expression, x minus 5. So now, again, I'm going to rewrite this as 2x minus 1. I've got a plus there, no negative sign, so just plus x and minus 5. Now, 2 x's plus an x, again, that's going to be 3 x's. I'll move this up. And I still have my minus 1 and my minus 5. Minus 1 minus 5, that's going to be minus 6. Remember, if you type that in your calculator, minus 1 minus 5, minus 6. Going more negative with that. So now we have 3x minus 6. And that is our answer. Let's take a look at some more. Hopefully this is starting to click for some of you. Let's do 2x minus 3 plus a negative x plus 4. This part might be a little tricky for some of you. I'm going to try to explain that and make it a little easier for you. So I have 2x minus 3, and since I'm adding this stuff, I'm literally just going to write what's in here. I'm adding a negative x. That's the same thing as subtracting. I'm adding a positive 4. So I'm going to rewrite this like that. Again, this little addition means that you're adding all this stuff. When we go on to subtracting linear expressions, and we have a subtraction sign here, it's going to be very different. But for adding, all you do is you write down whatever you're adding right there. So I put my minus x and my plus 4. Now, just like with these ones, I combine the like terms. 2 x's, this time, minus x. So 2 x's minus an x. If I had 2 x's and I take one away, that leaves me with 1x. You can put the 1 there if you want to. You don't need it. but you can if it makes you feel better, that's fine. I still have my minus 3 and my plus 4. So now, minus 3 plus 4, if I pop that in a calculator, minus 3 or negative 3 plus 4, or minus 3 plus 4, however you want to think about it, that's going to leave me with positive 1. So now I have 1x plus 1. Now anytime you just have one of the variable, we don't like to write that 1 there. It's just assumed that if there's no number, the number's 1. So the correct way to write this on a test, and what you would see on a test, would be x plus 1. And that's our answer. So now let's, hopefully we're feeling pretty good about this. Let's go ahead and take a look at something involving distributive property. So let's take a look at this one here. Let's say we have 2 times quantity x plus 3, and we're going to add to that this linear expression 3x plus 1. So distributive property, this means 2 times each of these terms. So I have 2 times this x, that's 2x, and a plus 2 times a plus 3, so that's going to be a plus 6, because 2 times 3 is 6. Plus this 3x, if there's no sign here, what's the sign? Positive. So we've got plus 3x and plus 1. So now I've got 2x's plus 3x's, that's going to be 5x's, plus 6 plus 1. 6 plus 1 is 7, so I end up with 5x's plus 7. Alright, let's try another. And if you're feeling really confident after I write this, as always, you can pause the video, try and do this, see if you can get it on your own. I think you'd be able to do it at this point. Hopefully you feel that way too. Give it a shot. And alright, hopefully by now you tried it, and if you didn't, that's alright too. So we've got 5 times x, that's going to be 5x. Positive 5 times a minus 4. Signs are different, so it's going to be minus, and 5 times 4 is 20. I've got a plus there, so I'm going to write down everything I have here. This 2x term, since there's nothing in front of it, assume it's positive, so I got plus 2x, and I have a minus 7. So now, 5x's plus 2x's, that's going to be a total of 7x's. I've got my minus 20 and minus 7. Well, negative 20 minus 7, that's going to be minus 27. So I have 7x minus 27. And there is our answer. Now, your book also has an interesting example here that I want you to look at. They had a picture of a triangle, and they said this side is equal to 3x minus 3 centimeters. This is equal to 2x plus 9 centimeters, and this is equal to 5x centimeters. Now, I know this is a lot of variables. It looks complicated. It's really not. They wanted you to figure out what the perimeter is of this triangle. They tell you that the value of x is 5 centimeters. So if you know x equals 5 centimeters, let's take a look at this. Well, perimeter is the distance around a closed figure, all the way around. So the perimeter of any shape is going to be the distance all the way around it. So the perimeter for this is going to be this, plus that, plus that. So now they're giving you 3 things to add up. Let's see how this works. We've got 3x minus 3 plus 2x plus 9 plus 5x. So now let's take a look at it. It should be a piece of cake. I've got 3x minus 3 here. This 2x, there's nothing in front of it, so I assume it's positive. So I got plus 2x plus 9. Right here, nothing in front of it, so I assume it's positive. So I have plus 5x. And now let's just combine our like terms. I've got 3x's here, 2x's here and 5x's here. Well, 3x's plus 2x's, 3x's plus 2x's, that's going to be 5x's altogether. And then add that to 5 more x's. Well, 5 and 5 is 10, so that means I'm going to have 10 x's. And then here, I've got still have this minus 3. I use those. I still have that minus 3 there. And I also have this plus 9. Well, negative 3 plus 9 would be positive 6. So I'm going to have 10 x's plus 6. And remember up here, the x is equal to 5 centimeters. So what I'm going to do is I'm going to put this 5 all the way in here for that x. So, move that up there. 10 times 5 plus 6. Well, 10 times 5 equals 50. So now I have 50 plus 6. And if any of you are wondering, why did I do that multiplication first? Remember, PEMDAS, order of operations, multiplication division before addition and subtraction. So now I've got 50 plus 6, that equals 56, and our units were centimeters, so the perimeter is 56 centimeters. And boys and girls, that's adding linear expressions. Have fun.